This is Module 4, Lesson 12. For this lesson, each group will need one of these, one of this paper, and a paper that looks like this. If yours doesn't have the shape names written on them, pause the video and write those on there. And then cut them out. Maybe write it on the back or cut it out and then write the shape that I have so you're sure you know which shape to pick up. All right, we're going to start with this page. I want you to fold it in half right along this little point right here, this tiny little angle. So make sure it's folded in half on there and then cut it out on the dotted lines. All right. Now I want you to unfold it and I want you to talk about with your partner or your group the attributes. Attributes are like characteristics. It means what do you see? So if you were to tell the attributes of me or of your partner, you might tell what color hair they have, what color eyes they have, how tall they are, things like that. In a shape, when we look at the attributes, we want to know maybe how many sides does it have? 1, 2, 3, 4, 5. So we know that it is a pentagon. Want to know how many angles it has. Are they right? Are they obtuse? Are they acute? So pause the video and talk about that with your group, and then we will talk about it. All right, some of the attributes, we know it has the 5 sides. It has some right angles. How many right angles does it have? 1, 2. Good. And then look at the other angles. Remember that you sometimes have to turn your shape to see. I can see this would be a right angle. So there's one obtuse angle. This looks the same over here. So this would be a right angle. There's another obtuse angle. And then what about this angle at the top? This would be my right angle. So this is an acute angle. What did you notice when you fold it in half? It's the exact same on both sides. When something is the exact same on both sides, that's called a line of symmetry. And so look at this. This is our vocabulary word, line of symmetry. It's an imaginary line on a shape. Let's try to read through the back, about which the shape can be folded so that its 2 parts match exactly. So today we're going to make real lines of symmetry, but when you look at different shapes, there's imaginary lines. Okay, so let's just say this bottle. I can't fold this, but I can see that it's the exact same. This is a line of symmetry down the middle. It's imaginary because when I cut it right there, or I draw the line right there, on each side of the line, it's like they mirror each other. They're the exact same. All right, so what we're going to do is we're going to look at different lines of symmetry. I want you to take your rectangle. It's one that looks like this. Okay, I want you, with your partner, to fold it as many times as you can where both sides will be exactly the same. So once you fold it, unfold it before you refold it again. Okay, don't like let's say with this shape, don't fold it and then say, oh, let me see if I can fold it for a line of symmetry again. It's the full shape. All right, so I can see that this one only has one line of symmetry because if I were to fold it this way in half, both sides would not be the exact same. All right, so every time you try to fold it, unfold it and start from your full rectangle shape. So pause the video and I want you to do that quickly. All right, how many lines of symmetry did you find in your rectangle? I found 2. Trace the ones that you found. You can see that it can fold in half this way and be exactly the same, or it can fold in half this way and be the exact same. In order to have a line of symmetry when you fold it, they have to meet exactly. It has to be the exact same on both sides, just like a mirror. All right, I want you to try that with the square. Fold it as many times as you can to make lines of symmetry and then draw it. Pause the video to do that and then check how many we got. All right, how many lines of symmetry did you find? Should have gotten one across and up and down, that's 2. And then a square, because it has 4 right angles and they're all, each line segment is the same size, it can fold diagonally in half each way, because 2 triangles make a square, excuse me. All right, so the difference, you can see they both have 4 right angles. However, the rectangle has 2 long sides and 2 short sides, where the square has all the same sides. All right, I want you to use your parallelogram. A parallelogram is a rectangle that is slanted. And then the next one is a rhombus. And that's a square that is slanted. If your rhombus is not perfect, which it won't be if you're using this page right this second, what I want you to do is fold it for one line, what should be one line of symmetry. So not in half, but from one corner to the opposite corner. And then use your scissors to cut the little bit of extra. When I made them, I couldn't, the computer wouldn't let me measure it, so they weren't exact. It wasn't an exact rhombus or square. So once you do that, fold along the extra corners, the opposite corners, not extra, and then anything that's left over, cut that off, and you'll have a perfect rhombus. So I want you to pause, find how many lines of symmetry you can find, and then check it with our video. All right, how many lines of symmetry did you find on the parallelogram? Should have been 0. Even though our rectangle had 2 lines of symmetry, what does the rectangle have that the parallelogram does not have? Notice the angles. A rectangle has 4 right angles, but the parallelogram does not. So there was no way to fold it to find lines of symmetry. If you folded it in half, there was always something sticking out. It wasn't exactly the same. If you fold it in half this way, same thing happens. Okay, but on the rhombus, you should have been able to find 2 lines of symmetry because it has, the square is the 4 right angles, and then the rhombus is slanted or tilted to the side. So this doesn't have 4 right angles, but all the sides are the exact same measurement. So they'll meet up when we go across the corners. All right, try it quickly with the trapezoid and the circle. This is your trapezoid, and this is your circle. See how many lines of symmetry you can find. Trace them on there so you can see. All right, what did you find with the trapezoid? 1 line of symmetry. It can only fold right in half. So each side mirrors the other side. Good, what about the circle? Should look like a pizza. There's 4 lines of symmetry because I can fold it in half across or in half the long way, but I can turn it. And now this is half or this is half. All right, so a circle has 4 lines of symmetry. All right. So what I want you to do is with your partner, I want you to get this paper. You're only going to be looking at these top parts. Once you see figure 1, figure 2, don't do anything with those. What I want you to do is with your partner, check and see. You can fold if you need to. You're not going to cut them out. But I want you to look at each shape and see, are there any lines of symmetry? Is there anywhere where you can draw a line and on each side of the line, the shape will look exactly the same? Just a clue, not all of them will have lines of symmetry. All right, so talk with your partner and work on those. All right, which shapes did you find that only had one line of symmetry? And before we look at my answers, I want you to remember that these aren't just shapes. These are pictures. So wherever you draw a line of symmetry, it has to look the same on both sides. So don't get tricked up by the one that looks like a circle. Which ones had just one line of symmetry? How many shapes had one line of symmetry? 5 shapes. Okay, so your A should have had just one line of symmetry. Same with the smiley face. Why does the smiley face only have one line of symmetry? Because it has a face on it. If I was to cut it in half right here, even though the circle would be the same, is it the same above my finger as below? Above it has 2 eyes, below it has a smile. The heart has one line of symmetry. So does that lobster and the butterfly. Okay, look at the 2 lines of symmetry. The H has 2 lines of symmetry. I can cut it down the middle, and they're each the same, or I can go in half here. And if I were to fold it, you could check it with your straight edge. You could check it by folding it. Draw the straight edge across right in the middle, and you'll see that they're both the same. The star was a little tricky one. Did you get the 2 lines of symmetry? The only way I saw 2 lines of symmetry was when I turned my paper. Then I said, oh, that star looks the exact same as it did this way. All right? And then which ones did not have lines of symmetry? That hand, even though it has 5 fingers, and I thought, oh, I could split it right in the middle. They each have 2 fingers. Are the 2 fingers in the same spot? No, your thumb is way down here. That's not the same as where your pinky is. This curved arrow does not have a line of symmetry. Okay? And the front and the back of this car, although they look about the same shape, they're different. This has headlights. This has a different size windshield. They're not the exact same. A line of symmetry is like a mirror. It's the exact same. All right? So if there's anything different, it can't be a line of symmetry. Look, this one has a door handle where the back door or the back area there does not. All right, I want you to look at figures 1 and 2. And these are we're going to work on lines of symmetry, but this isn't a complete shape. The dotted line that you see there is the line of symmetry. So you're going to complete the shape. I want you to talk with your partner and figure out, don't do it yet, but figure out, talk to each other. How are you going to finish the rest of the shape? How are you going to know if this is your line of symmetry? How are you going to know what to draw? Pause the video and talk, and then come back to check. All right, did you say that you were going to count in the grid? This is the line of symmetry, so whatever is on top has to be below that line. So how many boxes up does it go? 1, 2, 3, 4. So how far down does my line have to go? 1, 2, 3, 4. You should draw your line 4 down. Same on this side. And then how many boxes across does it have to go? 1, 2, 3, 4, 5, 6. 6 across. So pause the video. I want you to do that and then check it with mine before you do the other one. Does your shape look like that? If you folded it right on this dotted line, you would see that both sides are the exact same. Talk with your partner and do this one. Even before you draw it, try and figure out, what shape do I think that's going to be? It's one of the shapes that you already have cut out. So use the word to name it, and then follow what you think you're supposed to draw the rest of the shape along its line of symmetry. What shape did you get on figure 2? Did you say trapezoid? This one was a little bit harder. I want you, if you haven't already, talk about how you created that. I did a couple of things. I used my protractor. I also folded my paper in order to see it. One of the things that's really difficult on here is that I had to trace the lines in order for you to see it. you can't even see probably on this page. I'll show you. Can you see that there's grid lines on there? They were so light, they were hard to see. So the grid lines may not have been exactly perfect, but one of the things you could have done was just counted over how many you needed to go, and then on the top and the bottom, and then connect it with a slanted line. Connect it with a slanted line. You could have extended the lines in order to measure them, like I did, measure with the protractor and measure it together like that. All right, so you are just going to be practicing with these. You should have your problem set. I'm not sure that I have mine right here. But you're going to practice. I'm looking for it, but I don't see it. I'll probably find it the second the video is over. All right, you're going to practice with lines of symmetry and with using the grid to construct your own shape that is symmetrical. That's what we call it when you have a line of symmetry. When it's the exact same on one side as the other, then it's symmetrical. So they'll give you the line of symmetry and you use their grid. They're much neater than this one. They were darker lines on your problem set, but you'll use the grid to count how many boxes you need to go in each direction in order to make it symmetrical. All right, so practice with that and you are going to do awesome.